right, so how did it go? So were you able to determine the number of moles that are in your name? Like, were you able to do that? Okay, so some of you probably have some questions about, well, how do we calculate that? Like, okay, so maybe I understand, like, how to get the atomic mass or the molar mass. That's what I prefer to call it. But how do we go from there? Like, what is going to be our starting point? Okay, now I'm just going to use an example. I'm totally making this up. So let's just say that I weighed mine. And hold on, I'm going to come up here and I'm going to find me another page. So here is my page, and so I'm just going to make this up. So I'm just going to pretend like, you know, I took the chalk out there and I massed it first. So using the triple beam balance, and the mass of my chalk was 4.2 grams. Like, let's just pretend like I was using a really tiny piece of chalk. Okay, and this, of course, is going to be calcium. I believe that your lab calls it calcium carbonate. Let me double check and make sure. Yeah, so they're calling it calcium carbonate, and they were asking me about its atomic mass. Okay, so I'm going to use that skill set that I just got with the disodium chromate. So calcium's mass is 40.078, and then carbon is 12.01, and then with oxygen there are 3 of them. I don't know what I'm thinking here. Let me erase that. That looks like a hot mess. All right, there are 3 of them, and each one are weighing 15.998. And so, of course, you're going to have to multiply and add them together. So I'm moving away from you. I'm looking for my calculator. I found it. Okay, so let's go ahead and do this. So let's say 40.078 plus 12.01 plus 3 times 15.998. Of course, I got 100.082. And I'm just looking back over my numbers to check because you guys aren't with me to kind of proofread my stuff. Okay, now this is the same thing that we just did a while ago, is determining the molar mass. I mean, this is really not a new concept for you now. Okay, but let's see where we can use this, and I'm hoping that maybe you're starting to see, oh my gosh, when she was talking about paying attention to the units, here we go, Flo. All right, so 4.2 grams of calcium carbonate, and they're wanting us to, let's just do molecules for right now. Let's just do molecules. And I'm going to set up my fraction just like I did with dimensional analysis. And if you notice the molar mass right here, what unit is in the numerator? Well, that would be grams. Well, where do you need to put it to get rid of it? I would have to put it in the denominator. Well, what are we looking for? We're looking for moles, and then, of course, molecules. We're going to take it a step further. But I got to get some moles first. This is your go-to guide. You got to get some moles. So I'm letting the units dictate where I put my measurements. This is what I'm starting with. This is what I just calculated. So 100.082 grams in 1 mole. And, of course, you're just going to divide this number. We're going to say 4.2 divided by 100.082, and I got 0.041966 moles of calcium carbonate in the piece of chalk that I measured. So this would be, like we said, moles is a pile or mound that are found in this many grams, yes? And this is significantly less than this right here, so we understand why this number is going to be smaller than this mass here. Now, you can take this one step further, and I'm expecting you to do this. And I think your lab has got it broken down into maybe atoms, or the number of atoms. Let's see. Hold on, I'm looking at your calculations, because there's different variations of this lab. The question is, which one did I give you? Yeah. All right, so calculate the number of molecules. Let's do that. So let's calculate the number of molecules. We're going to take this one step further. And remember, you can go back and listen to this over and over and over again and see these examples done. But let's take a look at this. All right, so I'm going to start with this right here. When I told you earlier that in 1 mole we have 6.02 times 10 to the 23rd atoms, well, we also have molecules. We also have ions and formula units. So I can interchange any of those units to fulfill my 1 mole conversion. And let me show you how this works. Now just put your pencil down and listen to me. So this is the amount of stuff that I just calculated using what I measured from the triple beam balance. So I measured this, right? I calculated this. And now I'm going to use this. So let's start with this. So 0.04199656 moles of calcium carbonate. And I'm telling you that every 1 mole is going to give me 6.02 times 10 to the 23rd. Let's go ahead and just talk about molecules. All right, because that would be compounds and molecules. So for every 1 mole, and I'm putting mole in the denominator because mole is in the numerator here, and I need them to cancel. And I'm going to put 6.02 times 10 to the 23rd molecules on top because that's what I'm looking for, and I'm using that number because that's what it says, that 1 mole of any substance, I don't care what it is, has this many molecules in it. And of course, you perform the mathematical operation of multiplication. All right, and I get 2.56 e to the 22nd molecules of calcium carbonate. All right, calcium carbonate. So and you can't really see my decimal, can you? 2.56 times 10 to the 22nd molecules of calcium carbonate. Much because this is why it's imperative that you understand the movement of units. You understand where they are, that you fully wrap your mind around numerators and denominators and what this fraction is going to look like because it's the unit that's going to hinge that. Now I do want to go back to our original example with the disodium chromate. It said how many grams does 1 mole weigh? It weighs this. So for every 1 mole of disodium chromate, she has a mass of 161.934. And then it says, well, how many grams does 1 molecule weigh? Well, what do you think? 161.934. Okay, let's skip ahead. All right, now we're going to take this out. We're going to take this context. Let me clear some screen here. And we're going to look at an example, another example. We're going to work through this one together, and then I'm going to give you an opportunity to work one by yourself. But Roundup. So this is the herbicide manufactured by the company Monsanto, who is also one of the #1 manufacturers, I think, of GMO products, I think. Don't quote me on that, but I think. Has the formula C3H8NO5P, and they want us to figure out how many moles are there in a 500-gram sample of Roundup. Okay, so I think I have everything that I need, and I'm going to underline stuff. All right, they said give me a mass, and they've given me a formula or a compound, and they're asking me for how many moles. Okay, so here's what I do know, and I'm just going to kind of write, say, 1 mole is equal to 6.02 times 10 to the 23rd atoms, or molecules, or whatever. Okay, I always write that down just to help me remember and just to keep my focus. But the only thing that they're asking me for are moles. Can I get to moles? And if you remember, with that first thing, we calculated the molar mass. Okay, so that's the first thing that you're going to do 9 times out of 10 is calculate the molar mass. So we've got C, H, N, O, and then P. And of course we have 3 times 12.01. We have 8 times 1.008. We have 14.00. We have 5 times 15.998. And then we have phosphorus, and I always have to look at her, but she's 30.97. So 30.97. And of course, I've got to add all of those up, multiply and add all of those up. Don't forget to do that. And I end up with, let's see, I think it was 168. So 168.964. As always, please double check my math. Okay, so 168.964. This is the molar mass of our the formula for Roundup. That's going to kill these weeds and things in my garden. But we're going to start with what we're given. So this is the initial. So let's say 500 grams of C3H8NO5P. Okay, now you're starting to see a pattern. Are you starting to see a trend here? So if grams is in my numerator, it needs to be in my denominator. And of course, I'm looking for moles because it said how many moles. I'm going to put that on top. Well, we did something that incorporated both of these units. We worked with the molar mass. So I could easily say 168.964 grams in 1 mole. And when I divide these numbers, I get 2.96 moles in this compound. 500 grams of it. It is really that simple. Okay, so we're going to skip this next one right here. We're going to come back to it because it's got something very interesting associated with it. It's got water associated with it. But I want to get you comfortable with this before I start throwing you some curveballs. So let me clear my screen very quickly. So the next question that I want you to do is looking at iron. It's biologically important in the transport of oxygen by the red blood cells. And this is a challenge. It says in the adult human there are approximately this many red blood cells. So there's this many. And this is the mass of iron. Okay, so I'm thinking, Munchkins, that this is probably pretty important. And they want me to calculate how many iron atoms are present. And then they've given you the molar mass or the molecular weight. These terms are interchangeable, so I want you to try this and see what you can do with it. So go ahead and hit pause. And then when you get done, come back to me. Okay, now as you can see, so the problem has we've kind of looked at this one, and I'm hoping that you took a bash at it. And it's okay if you're not getting this to begin with. You just started learning this, and it is going to be a process. All right, so what I did was I went ahead and worked with the grams of iron because that's what I was given in the problem. And that was very similar to what I had done earlier. And I incorporated the molar mass of iron here, and I got 0.0519 moles of iron. And then you'll notice I have the second step because they're asking me how many iron atoms. So I need to get to atoms. And if you guys remember, we said 1 mole of any substance is equal to 6.02 times 10 to the 23rd atoms of any substance. I don't care what it is, if it's iron or lead or what. So in 1 mole of iron, there's this many atoms. And I came up with this number, 3.13 times 10 to the 22nd atoms. Now they said they wanted to know present in each red blood cell. So then I went back to the problem and I had to pull this information here and I divided it. I mean, very easy for you guys to get that. So the answer ends up being 1.20 times 10 to the 9th atoms of iron per red blood cell. Okay, so this lesson is an introduction into the molar mass and just kind of working with Avogadro's number. The next thing that I want you guys to do is I want you to work on your bubblegum lab. So I want you to consult the handout that's been provided. I want you to take a look at it, collect some data, and give us something to talk about on Wednesday. See you then.